Welcome to a review of how to find area of rectangles and triangles. If you are in my class, you should have your foldable sheet ready and you should be completing this through Edpuzzle. The first thing I want you to remember from elementary school is that area is the amount of square units in a rectangle. So for example here, you can see that we actually have square units. So let's just pretend these are centimeters. They're pretty close. So if that was 5 centimeters and these units were, this was 3 centimeters, then I'm literally looking at how many square units would fit into this rectangle. So if I counted them out, then you would see I have 15 square centimeter units. Of course, we don't need to count them out like that. We could literally just multiply these, which is why we have the formula base times height. In elementary, you may have said length times width, and that is the exact same thing we're talking about. In 6th grade, our formula chart says base times height, so that will be our main focus. So go ahead and grab a color, and all I really want you to do is highlight the base and height of each rectangle that you see here. So I'm going to call this my base, and this is going to be my height. It's important to remember that bases and heights meet right at a right angle, so if you do not have a right angle, then you do not have a base and height and probably need to create that. On my next rectangle, I'm going to go ahead and just again highlight my base and height here and just have that labeled so that you understand that importance. I may even take another color and kind of circle that right angle just to show that that's what we're looking for. We're looking for the connection of that right angle. So let's look at some real world examples. The American flag from the Super Bowl is represented below. How many square yards was the Super Bowl flag? We always want to start by showing the formula, substituting, then solving. So this will be a requirement in our classes. Let's start with the formula. We know that we are searching for square yards, which is like the square units that we just talked about. So in this case, we are going to use that clue that we are looking for area. So I need area, and this flag is a rectangle, so I need the formula for area of a rectangle. That is area equals base times height. We always start by writing our formula. Next, we are going to substitute. So I can see here that this flag has a base of 32 yards and a height of 12. So I'm going to write 32 times 12. I know this is my base and height because it meets at a right angle. So I'm going to go ahead and solve this. Please pause and solve it and resume when you're ready. Okay, I've completed my multiplication and I came up with I have 384. Now we need to make sure that we do our units correctly. So we have yards, but since we just found area, we need to make sure that we square our yards, and that is the amount of square yards in the Super Bowl flag. Our next question says, Stephanie needs a cover for her L-shaped pool. How many square feet of vinyl will be needed to cover the water? Remember that area is covering. We are covering a surface, and so in this case, even though they don't ask us what is the area of the cover, we know that it's area because of a couple clues. We see how many square feet, so if we're finding square feet, we're looking for area, and then we also need to cover the water. So as you can see here, this is not a rectangle, but it is a composite figure made of rectangles. So that's what we're going to use. And you could cut this up into two different ways, really. You could go ahead and slice it up into 2 rectangles like that, or you can do what I'm going to do and cut it into 2 rectangles like this. So what we can do is find the area of the upper rectangle and the lower rectangle. So because I know I'm working with formulas for a rectangle, I'm going to do area equals base times height. Now I don't have substitutes here because I have 2 rectangles, so we're just going to do 2 separate formulas here. What's really nice about choosing this rectangle is that I have my base and my height right here. This is my right angle, and I have both of those units. So I'm going to go ahead and substitute inside this rectangle. 43 times my base times my height is 21. Go ahead and solve. So hopefully you got 903. So inside this rectangle, I'm going to go ahead and put 903 feet squared. So this just helps me stay organized. I like it when I can actually write in there. Now this rectangle on the bottom is a little smaller, so I probably will not write inside that rectangle. So we have some issues with this next rectangle. We don't actually have the side lengths. Now it kind of looks like a square, but we cannot determine it's a square until we've actually done that mathematically. So the first side length I'm going to look for is this green one right here. Now what I know is that this is a vertical line. So what I know is that 40 is a vertical line and 21 is a vertical line. So I can actually find this side length by doing 40 and getting rid of the 21 in my way. So this should give me a difference of 19. So that side length is actually 19 feet. The next thing I'm going to do is go ahead and look at this horizontal line, and I'm going to look at my other two horizontal lines. I have 43 and I have 24 for horizontal lines, so I can find the difference of those, 43 and 24, and that actually gives me a difference of 19 feet as well. So what we have discovered is this is a true square. So if I'm sticking with my formula, area equals base times height, then I need to do the substitution of area equals 19 times 19. Go ahead and work that out. Hopefully you got 361 for the area of our square, and that is 361 feet squared. If you had room, you could pop it in, or I'm just actually going to use an arrow to show that that's the area. So to end this up, we want to cover the entire water, so we need to cover the entire L-shaped pool. So I'm going to go ahead and find the sum of these two areas. So I'm going to do 903, find the sum with 361, and then the total area of our L-shaped pool should be 1,264 feet squared. Our next problem says, Cori designed a blueprint of the porch she wants to build in her backyard. What is the area left for grass on her blueprint? So a blueprint is just a piece of paper that kind of sketches out your idea. A lot of times businesses use them, not just a piece of paper, but it's very professional. So the first thing I notice here is that I'm missing some information. This is also a composite figure, but it's overlapping composite figure where you have two figures on top of each other. So hopefully you can see that we really have two rectangles we're going to be working with here. The first thing I need to figure out is the area of this porch. So I see that I have a horizontal base here, but I don't have the distance for this piece on my paper. So I need to figure out what are the other horizontal lines that I can connect this to kind of find this dimension. So I can see the whole way across is 30, and then I have this little 8 centimeter piece. So I need to get rid of the 8 centimeter piece and find the difference. So we're going to do 30 minus 8 so that we know now that this section is going to be worth 22 centimeters. We are going to do the same thing vertically. I can see that I have a vertical total piece here of 15 centimeters, and I have this little guy that's only 4 centimeters. So once again, we're going to find the difference. I'm going to do 15 minus 4, and that's going to give me that this dimension is 11 centimeters. So this missing dimension right here, which now allows me to find the area of the porch. So we know this is a rectangle and the area is base times height, and then we need to do our substitution, which is 22 times 11. So go ahead and work that out. So hopefully you got 242 centimeters squared. Now, since these are overlapping, kind of imagine that your backyard was covered in grass to begin with, and the whole entire backyard was grass. So all of this was grass, this whole entire rectangle. Except now, Cori's building this porch. So we don't want the whole thing to be grass anymore. We just kind of want this L shape that's left to be grass. But because the whole thing used to be grass, we can find the area of this entire rectangle right here and then just find the difference of the two. So that's what we're going to do. We know that the dimensions of that entire rectangle is going to be 15 and 30. So I'm going to go ahead and I always start with my formula, area equals base times height. Area equals 15 times 30. And if you work that out, you should get that area is 450 centimeters squared. Now that's the entire rectangle right now, including the grass and the porch. So to end this up, we need to find the difference between the two. So to find this gray shaded grassy area, we need to go ahead and do 450 minus the porch, which is 242 centimeters squared. And once you find that, your difference should be 208 centimeters squared, left for Cori's dog to run around and have some fun. So we've been discussing area of rectangles, and you can see this rectangle here. If we were to find the area of this rectangle, it would just be area equals base times height, which would be 6 times 10, which is 60 centimeters squared. But what you can see is that I have this line dividing this rectangle into two halves. Well, what you can see is what's been created are actually two right triangles. So if I wanted to find the area of this triangle, I literally could just do half of the 60 centimeters squared that I originally got to find out that the triangle's area is 30 centimeters squared. So this is going to guide us into our formula for area of a triangle. I have two quick examples here again. Notice that if you take a rectangle and you divide it evenly into two pieces, and this is even, and it always makes a triangle. So even here, this area, I can see that if I divide that up into two sections, this right triangle on the outside, 1 and 1, those would be equivalent to this triangle number 2. And so we would just take the overall rectangle's area and divide it by 2. I hope that makes sense. So let's go ahead and just practice this. So here's our first look at this. You can see that just like in the rectangles, we have this gridded area, and if you were to literally count up all those little squares, you could find the area of this triangle. But let's go ahead and talk about what students maybe have a harder time doing, and that is finding the base and height on a triangle versus a rectangle. A rectangle has beautiful right angles, but triangles don't always. So let's look at this top triangle. There is not a right angle to be seen. So we need to go ahead and create a right angle. So what I want to do is go to the top of my triangle, and I'm going to create a 90-degree angle down to the base. Now I'm calling this my base. So this is my base, and now I have a height because now I have this connection at a right angle. So technically for area, you do not need these additional side lengths. So sometimes students kind of think you need that, but they are not really necessary. So let's go ahead and look at this right angle. This is a beautiful right triangle, so we know that we have a base and height right here because that meets at our right angle. So right triangles are kind of more friendly than triangles that are not right triangles. Again, right here you can see that this is, they had to create this right angle, And so that is why this is our base and that is our height. And I just kind of like to circle the right angle, because if you circle the right angle, then the two sides that are, the two lengths that are touching that are your base and your height. So let's practice some real world examples. Here I have a Dorito chip. The average dimension of a Dorito chip are shown below. What is the area of the Dorito chip? Just like rectangles, we are going to do a formula substitute solve. So the formula on your formula sheet is area equals half of the base times height, just like we saw in those models. So my substitution for this is area is going to be half of the base, which is 4 2/10, times your height, 3. So what I always like to do is think about commutative property here. I need to take half of something if possible, because that makes this really nice. And I can see that half of 3 is going to give me a decimal, so I don't love that. But I do kind of love taking half of 4 2/10. So I'm going to solve, and it's one extra step than a rectangle. So I'm going to go ahead and take half of 4 2/10. So now I'm going to have area equals half of 4 2/10 is 2 1/10, and I still need to multiply times 3. So I've used up a piece of it. Sometimes I have a strategy of saying like, okay, this is the part that I've already done, so I don't accidentally bring those down. Also, I kind of caret this down and say that's what I've done. Then you just need to finish up with that multiplication, and area of a Dorito chip would be 6 3/10 centimeters squared. Our next problem says, Robert is going to paint the triangular wall under his staircase. How many square feet does Robert need to cover with paint? So you can see here we have a 7 foot by 9 foot right triangle. So I definitely need my formula. Area equals half of the base times height. And my substitution would be area equals, remember we're looking for that right angle, so that's why I'm going to use 7 and 9 here. Let's say they did give you this dimension 12 feet. You just would not need that 12 feet to solve this. So I'm going to go ahead and do half of the base is 9 and the height is 7. Now, I look at this and I think there's not an even number. I don't really want to deal with decimals if I don't have to. So using commutative property, I know that I can actually multiply 9 times 7 before I do anything else. So I'm going to bring down the half. Area equals half of 63, 9 times 7. Again, like I showed you before, you can kind of show I'm choosing to do this first and caret that down so you're staying organized. Now to find half of 63, you could definitely multiply half and 63, or you can divide 63 by 2. So I'm going to do that. And if you did that correctly, you should have seen that Robert's going to go ahead and need to make sure that he can cover 31.5, let's see, feet squared. So that lets Robert know how much paint he needs to grab at the store. For our final question today, the area of a sail on a Sunfish Sailboat is 66 feet squared. If the sail has a base of 12 feet, what is the height of the sail? So this is a different kind of question because we're actually given the area. You can see this is 66 feet squared, and that feet squared definitely tells us its area, plus it says the area of. The next thing I know that I have a base of 12 feet. So what I like to do is label everything I know. I know this is 12 feet, so go ahead and get that labeled. Also off to the side, I would probably just state, I know the area is 66 feet squared. Now what I don't know is this height, so I probably would draw this, and actually that's a great idea. Go ahead and do it. Show that that meets at a right angle, and the height is what we are looking for, and we don't know. So let's go ahead and use the same formula. We still need this formula for area. Area equals half of the base times height. Except this time we know some different things. We know the area this time, so you're not going to bring down that A. You're going to substitute the area with 66 feet squared, and then half just stays half in your formula, so we'll bring down half. And then we know our base is 12, but we do not know our height. So I'm going to go ahead and use parentheses here and just put that the height is going to stay our variable h. And then we're gonna combine like terms here. So you can tell me what half of 12 is, whether that was an even number or not. You can complete half of 12, so my suggestion is that's what you would do next. Half of 12 is 6, so you would bring everything down. 66 equals 6h. And then you're left with a multiplication equation, so we need to solve this multiplication equation to solve for x. Go ahead and do that. So notice I have divided both sides of this equation by 6 to isolate the variable, and 66 divided by 6 is 11. You need to be very careful not to put feet squared on this. I'm not looking for the square units that cover, I'm looking for a length, which is the height. So this is just 11 feet. I hope you learned something new and got to experience this in a real world way. Good luck.